Hello students, welcome again to the new segment. In this segment, we will be looking at some more properties of the KNN classifier. So remember that we have been using two syntaxes in order to build a particular KNN classification model. In the first syntax, we just use the FITC KNN along with only two parameters. One is the table which contains our data, and along with its corresponding response variable name, right? And then of course we assign it to some variable, let's say m. The second syntax that we have been using is that we mention some additional parameters over here. For example, number of neighbors, and then we specify its value, let's say 5. So this form is actually known as the name value pair form. The name of the property and then its corresponding value. So the name of the property, value, so name, value, pair form. So there are essentially different types of name value pairs that are available with the FITC KNN algorithm, and they actually correspond to the different properties that you can modify for a particular KNN classification model. And these properties has essentially 3 categories. So I will write those categories so that it becomes easy for you to understand. So one are those properties which you can set only at the build time, or at the time when you are building your classifier. So for those properties, ideally, you should mention it within when you are trying to build your model, and you should specify it as a name value pair argument along with the table and the response variable name. The other type of properties are those properties which you can set after the model has been built. And the second type of properties, they can be accessed once we built our model. Remember, there are no quotes because it is a numeric value. Right. So once we have built the model, we can access the second type of properties with the dot notation. So m dot and then the property name. So if you want to have a look at all the available properties, they are listed over here. So you can access, for example, the number of neighbors. And then you can specify some value for that. Okay, the final type of properties, that is the third type of properties, are the properties which you can set at the runtime or when you are building a model, as well as after the model has been built. Right. So the number of neighbors was essentially an example of this third type as well, right? So you can set it when you are trying to build your model, and after the model is being built, you can also set its values. Ideally, I would like you to set all the properties at the runtime, and then if you want to make some comparison by changing certain parameters, then you can access that using the second type of properties. Right, so these two these are the essential philosophy of having such type of properties. And when we try to cover some other classification models such as naive Bayes and SVM and so on, so then there will be certain this second type of properties and the first type of properties, the difference between these two will become very much clear, right? There will be certain properties which you cannot access once the model is being built. In the naive Bayesian case, these are the prior probabilities and so on, right? So the probabilities distribution, you cannot specify it once the model is being built. So there were a few examples. Now let us look at some of the name value pairs that you can modify and mention when you are trying to build your model. So for that purpose, you need to consult its corresponding documentation. So you need to write the function name over here, FITC KNN, and then go to its proper documentation. Okay, so this is the corresponding syntax that we have been using, right? So in order to look at all the available options, you need to click over here, that is name value pairs, or alternatively, you can scroll down here and look for contained value pair arguments. So when we click it, there are a whole bunch of different properties that you can access and you can specify while you are building a model. So we will look at some of the important ones over here. The first one is the break ties, which means that if within the neighbors, if there is a tie between two different classes, that is, both of them has the same number of nearest neighbors, so then you can mention some additional parameters, such as the smallest. In this case, it will use the class having the smallest index, right? So the class that appears in the class name as the first class, it is going to be the predicted class. Then the nearest one, it means that among the tied groups, use the class with the nearest neighbors. So there are, let's say there is a tie between two different classes, right? And then it is confused that which class to predict. So it is going to consider the neighbor that is the class of the neighbor that is the nearest one, right, among the neighbors that it has returned. And then alternatively, it can also use a random tie-breaking criteria. So there are three different options. This bucket size, it is usually used when you are trying to consider a KD tree, right? So since we are not considering that, we are just considering the nearest neighbor algorithm, simplest form, so that's why we ignore it for now. The categorical predictors, you can mention which of your variables are categorical, right? So there are again two options that you can specify as all or none. Then the class names, you can specify the class names if you don't want the default names to appear over there. Then the cost matrix, if you are considering cost sensitive classification, that is, certain classes have certain cost associated with it. Then the covariance matrix, if you are using the Mahalanobis distance, then you can consider this covariance matrix as well, and there are certain arguments that you can specify. The include ties, it is another useful property that is, it tells us that whether we are going to consider the exact k neighbors, or if there is a tie that is, there are two nearest neighbors at the kth distance, so it will consider all of them, right? So if by default it is going to be true, that is, if there is a tie between the kth nearest neighbors, that is, there are two instances that is having both the same distance, but they are located at the kth position, so they will consider both of them. If there are three, it will also consider that. Then there are some other properties, right? A lot of different properties. One of them is the prior. Right, so by default, it is going to be empirical. Empirical means that it is going to consider the class prior probabilities based on the relative frequencies of the corresponding classes within the data set. Alternatively, you can mention a uniform. A uniform option will mean that all the classes have the same exact probability. If there are k instances in your data set, then all the classes are going to be considered having the same class prior probability, where k is the number of classes. Sorry, it's not the number of instances. So if there are three classes, all the classes are going to have the probability of 0.33. If there are four classes, all the classes are going to have the probability of 0.25 each. Alternatively, you can specify a numeric vector, which means that you need to specify the values for each and every class yourself. So let's say, for instance, an expert has given you some values and you want to specify that, so you can do that. And the property name, of course, is prior. So let's do a quick example and see how we can set that. Right, so we need to say here the property name, which is prior, and then we can specify the probabilities by ourselves. Let's say in this case, we know that there are three classes, so we specify it ourselves. Remember that it must be summed to 1. So we can do that. And it will learn a model based on these prior probabilities. Then, looking at some more properties, of course, one of the property is the distance property, which is quite useful. And some of the some of the available options that you can try here is the city block distance measure, Chebyshev, correlation, cosine, Euclidean. This is the default option. Hamming, it is a default option when you are dealing with the categorical data. Jaccard, Mahalanobis, Minkowski, S Euclidean, of course, it is an extended version of the Euclidean where the variables are being standardized. So there are different, of course, you can also mention your own built-in function, but for now, I would just recommend you to play around with the existing ones. So in a nutshell, there are a whole bunch of different properties, right? And of course, you may not be interested in all of these properties, but for a general understanding, the Bragg ties property, the class prior property, right? Similarly, the weight, distance property. These are some of the very important properties that you should know. And of course, if you are trying to make very much customized KNN algorithm, so then you may be considering some of the additional properties as well. For some of these properties, we will be covering it when we are considering the evaluation of the KNN classification algorithm, right? So that's it for now. Hope you're enjoying the course. See you in the next segment.